I wanted to thank Laval VR for having me here. And today I want to talk to you about, well, two things, actually. VR, AI, and pain, and how we can do way much more than distract with VR for the treatment of pain. But also about a little bit the future that I see for digital healthcare and VR and AI all combined. So, today, I don't know if you have IT discussions with tech guys, but we cannot have a conversation without hearing data about 10,000 times in a conversation. We're really all about data. Data is the new gold, and it's nothing new. It's been 10 years that big data for healthcare is there. And for example, the International Data Corporation estimates that by 2020, we'll have 2.3 trillion gigabytes of healthcare data, and 2020 is next year. Fitbit, Apple Watch are generating approximately 2 trillion gigabytes healthcare-like data just this year. So we have a lot of data, and it's normal using it. But in treatment, what I wondered through my experience was, are we really a compilation of objective data? Aren't we missing something? Csikszentmihalyi, a psychologist that theorized flow experience that we're using a lot in VR, was saying that subjectivity was the thing choosing in our environment what we'll treat with our working memory, which is of limited capacity. So subjectivity is one huge thing that is completely overlooked. For example, there is a huge database in France, and it's an acronym. They love acronyms in France. And it's the Inter-Regime National System for Health Insurance Data. And it's a huge database. It's for healthcare reimbursements. They have approximately 1.5 million gigabytes data, but they have nothing on life journey, on socioeconomical status, family history, subjectivity. They have nothing. They have only real objective data. So I think that in general in healthcare, we're really missing this point of subjectivity. And this is also what I want to talk to you about. And we all know, working in healthcare, how subjectivity is important. Because, for example, this conference, nobody's going to live it the way I do. And this person here is not going to live it the same way as you will. And going back home, you'll construct on what you'll memorize from this, and you'll go on and build around that. But we'll not build the same thing. So subjectivity is really key, and key also for the potency of medical treatments. So I really think that is a big point to address, and specifically for pain. But let's start with pain and expand as we go. Because pain, well, pain is a pain, and it is a pain to define. Yeah, just a little heads up. I change slides with my nose, so if I disappear behind my computer, it's because I'm changing slide, not because I'm afraid or I don't know. So pain is a pain to define. You already have to do one distinction between acute pain and chronic pain. This is the most classical one. Acute pain is generally it's linked to a lesion, and it's defined as an unpleasant sensory and emotional experience. So you already see there the subjective aspect. It is unpleasant, and there is an affective part to it that is located around the insula and anterior cingulate cortex generally, but there is also this objective side, sensory discriminative side, that is located at the primary somatosensory cortex and the secondary. So you have those two sides. You have objectivity on one side, but you have also subjectivity on the other. And well, this is just brain mechanisms, but it's already enough complex like that, because you have also at the periphery, at the spine level, you have a lot of things happening for pain. And even if it shares a common word between acute pain and chronic pain is a totally different world. You have structural alterations. That's what you can see with FA. It's fractional anisotropy. It's a measure of white matter tracks integrity. So it's pretty much the structural objective connections between brain areas. You have also functional changes in chronic pain. So the way it gets triggered is completely altered. For example, there was a big study that did a coefficient, a unitary global measure for functional connectivity across the brain. And they used graph theory. It's more and more used in neuroscience. And what they did was measuring the degree rank order disruption. So it's pretty much the number of connections, functional connections. And they saw that, for example, the general measure could diagnose chronic pain. And if they were looking at really local degree disruption, they could say which type of chronic pain it was and differentiate between all the chronic pain conditions. So there again, you have functional side, which is linked to subjectivity, and you have also really structural, hardcore side, really pragmatic, that is more objective. So in pain, actually, I really discovered studying pain that subjectivity was key just as much as objectivity. But pain is also a pain for a lot of actors in the healthcare field. Pain is a pain for patient. There are 100 million people having chronic pain in USA. There are 150 millions in Europe. And the thing is, you have a vicious circle, because you start having persistent pain, you have those brain functional and structural changes, but it's often misunderstood because it resembles anxiety, depression. There are a lot of misunderstanding, misdiagnosis, and misprescribing. So you have an ontologic need that is totally unaddressed, and it leads to more persistent pain, and you start having a vicious circle for patient. But patients are not the only one that are concerned with chronic pain and pain in general. For institutions, for example, there were calculations made, and it's pretty much 10 million Swiss francs expenses that are due to practices variability in a 50,000 inpatient per year structure. And it's because 50+% of hospitals have no acute pain units. Generally, the assessment is the generic 0 to 10 rating, and it's done by a non-professional, and that's it. It's really, really fast. But the thing is, when you don't address pain correctly, it leads to poor surgery outcomes, cost rising, and you'll never get your acute pain unit. And it is also a burden for the healthcare system, and this is huge. For example, in United States, you have approximately $635 billion a year that are for chronic pain. And it is more than heart disease and diabetes combined. And you have a chronic pain prevalence that is going up. The system, the healthcare system, and all the costs are going up. You have phenomena like the opioid crisis that we're hearing a lot of right now. You have unemployment, and it is again a vicious circle of expenses for the system. So we really need to address chronic pain in general, and in chronic pain we need to address this subjectivity objectivity merger. And before really expanding on chronic pain, I just wanted to tell you a little bit about myself, because I don't specifically like talking about myself, but I have a really unusual relationship actually to pain and to healthcare in general. It was 5 years ago, I got struck by 15,000 volts. So I got burned on pretty much 60% of my body, was amputated of both arms. So I had an experience of pain that was pretty extensive, and of the entire healthcare system, insurance system, the whole deal. I had a relationship with them for like 3 years, more or less. And what I understood later is that I had pretty much all the worst pain you can get. I had neuropathic pain, I had phantom limb pain, I had burn pain, everything you can name, I had it. And what I did was I used my own subjectivity to treat my own pain. And in 6 months period, I went from having methadone, opiates, antidepressant, anticonvulsant, everything that they could give for pain, to nothing. And I did that only using my mind. I never took whatever. I didn't do stimulation, not electrical stimulation, only using my mind. And seeing that, a lot of people started to ask me, can you do the same for me? Because I was in an institution and pain is everywhere and everybody's popping pills pretty much all the time. And it has side effects that are horrible. You cannot find your words, you have hallucinations. It's hard to deal with. And so I got trained to be a therapist, and I really specialized in the treatment of chronic pain. I also went into operating rooms to replace full narcosis with the mind techniques that I developed on myself. Then I expanded from there, and I started to work on anxiety disorders, depression disorders. I also really worked on a little bit post-traumatic stress disorder. I went into sleep problems, addictions, because all of those are linked to pain. Because pain is going to trigger addiction mechanisms with opioids. Anxiety is closely linked to pain. It leads often to depression, and sometimes depression is what leads also to chronic pain. And you have an intermingling of all those factors into one big condition. And so I wanted to show you also a little video, because having treated pain for myself and for patients, I understood the big place for subjectivity. But I also understood that that actually treating chronic pain is not just about pain relief. It's not just about alleviate pain. It's also about discovering a big strength that we all have in our subjectivity, in our life baggage, in our everyday story, in emotions, and how to use them. And you can gain control over cognitive processes, body sensations, how you perceive the world and how you perceive to yourself. And all of this strength is not only applicable to pain, it's also applicable to a very wide variety of psychoproblematics, because I don't like to talk about psychopathology, because it doesn't have to be pathologic to be treated. And it allows you to go way further in everything. And this is what you can see, is that to test this method, since I have neuropathic pain in my feet pretty much all the time, I decided to try, for example, an ultramarathon. I did a 260-kilometer race with neuropathic pain in my feet. And that's what you can see there in the desert. And what I did was only using my mind to treat the pain, to manage my pain on the entire journey. And so treating pain is not just about alleviating pain. It's about discovering to your patient how much strength he has in his own subjectivity. So we really, really need to address subjectivity. But chronic pain is also very, very complex. It is a multi-level phenomenon. You have molecular level with, for example, there you can see it's calirin-7. It's a protein that participates into long-term potentiation. It's pretty much the strengthening of connection between neurons. And they have deficiencies, for example, in C1q, which is dendritic spine pruning. So pretty much you have more connections being made, but you have a mechanism to downregulate them. And this is deficient in some chronic pain conditions. But you also have, on the cellular level, you have a loss of inhibitory neurons that allow to control your pain. You also have a lot of changes in satellite glial cells at the periphery. You have also changes in brain areas and brain networks, such as I said before. For example, in the hippocampus, there is less neurogenesis, and the rhythm and the slowing down was correlated to the level of intensity in chronic pain, for example. But you have also psychological and social changes, such as I described before. And this will change the entire environment of the person. He's not going to live the world the same way he was doing before. So pretty much the entire system is being changed. And this needs to go inside the VR experience, because you cannot do simple VR experiences that are fixed. It needs to be adaptive, and it needs to take all of those factors into considerations. And you're going to tell me, okay, but how are you going to do that? Why VR? What's the deal here? Well, VR for me is a really special medium for delivering therapeutical interventions of all types, because it allows to have an impact on all of those mechanisms. You can create in VR, such as we can see all around with design. You can work on attention. You can even diagnose attention with VR games. It has been done actually by Mindmaze. You can also train attention. You can get access to memory. It is often used in dementia for older people. Emotional recall, that of course. You can trigger motivation for having more therapy for your patient, and you can interact with him. And all of that into a world that you create and that you control, and you can give the control also to the patient and make it adaptive. But in all of those, again, you have this subjective component. And there I put that image because I wonder if you saw the gorilla, the lion, or the tree first. And it's going to interact with everything. There, I have to admit that my scientific side is a bit annoyed because I made an arrow to this from the subjectivity to the molecular level, but because doing every arrow to every single level was, well, it wouldn't have been an image to show, so I decided to do simple. But we don't know if subjectivity is going to really impact the molecular level. We saw that there are some epigenetic mechanisms in chronic pain, for example. But is it also going to have an impact on brain networks, brain areas, and decomposition? And their subjectivity is definitely going to have an impact on social side, psychological side. But it's also to be taken into account in all those factors that you can use with VR. Because you're not going to caption my attention the same way you're going to caption the attention of somebody else. It is highly subjective, and it's highly dependent on the person. So you need to be able to build adaptive content according this subjective side, but taking into account this objective side. So you have a lot of computations to do to generate those experiences. And how can we do that? Well, of course, that's where AI comes in. AI will allow to build models, and it has already been done, because you have patient representations that are being built using those databases to predict when they will be readmitted in hospitals, if they're going to be readmitted in the 6 months. It's already has been done, and it works. There were precise 80% of the time, so it's coming. And this is possible because they found a good representation. But a big question to answer, and this is more my philosophical background, because I studied also philosophy talking, but what are the relationships between those levels? Who acts on who? Who explains who? Does the environmental, social, psychological side is 100% explained by the molecular level or the atomic level? It's a big question to answer, and AI can help in those, because she can pretty much try thousands of models and see which one fits best. But there are a lot of challenges, because when I talk about that, I also have skeptics telling me, yeah, AI is going to solve everything. We hear about that all the time. So I decided to put them out there, to be completely honest with you. You have all of those challenges just in healthcare. You have quality of data, because you have handwritten data, for example, and sometimes it respects the classification, the ICD-10 for diseases, but sometimes it doesn't. Sometimes it's really badly written, so it's hard to really read for a computer. You have a big heterogeneity and big questions around aggregability, because there are all different signals. An EMG is not going to be the same as handwritten notes. It's not going to be the same as ECG. And all of those are need to be put together, and it's really hard with AI. You have a temporality issue, especially in healthcare, because it's not just one event. It's a sequence of events that's going to lead to a disease, to chronic pain, for example. So you need to have models that are able to take into account this temporality aspect. You have a high complexity of every subfield, because, as I said, you have genetics coming in, molecular You have biochemics, you have cellular level, you have neuroscience, you have psychology, you have a lot of domains, and it's really, really complex each level. You have the quantity of data available, because we have a lot of data, but we have a lot of disease. And sometimes in some disease, we have very little quantity. And the big issue is interpretability, because in the healthcare field, we cannot just give a diagnosis. AI needs to be able to explain what she did. What are the paths that she chose? But there I have a good news, because we have a way to solve all those challenges, and solutions are being found pretty much all over the world. For quality, we have algorithms that allow to enhance the quality and to clean all the signals. And for example, at Mindmaze, we did it. We're totally capable of interpreting pretty much 30 different inputs from the EMG, so the muscular activity of the face, and we clean those inputs for them to be readable. For heterogeneity and aggregability, recently they used Deep Boltzmann machine, which is unsupervised learning, to do multimodal learning. So it is totally feasible. For temporality, you have recurrent neural networks that allow to model temporality, and you even have long short-term units where you can decide how much information goes in and how much information goes out through different timescales, so that you can really model this temporality issue. For complexity, you have all decision trees and all those old approaches that you can use. For quantity available, well, we have generative adversarial networks coming in big time to generate data. So you can pretty much produce synthetic data that really take into account the pattern of the data. And for interpretability, same again, you have solutions with autoencoders, decoders. So we have solutions for each and every one of them, but those solutions are being explored separately in different subfields all over the world, in different academics. So we really need to put all that together. And generally speaking, we have another challenge, which is sparsity. It is split all over the world between different institutions, different systems. We have big security issues to address as well. And quantity over time, because in healthcare, you cannot wait 20 minutes to tell someone, ooh, you're going to have a heart attack. You need to be fast. You need to be there. But then again, for all of those, you have solutions. You have a big network change that is coming, 5G, but you also have edge computing paradigms, where we put the computing on the edges of the network with, for example, fog computing or mobile edge computing, mobile cloud computing. You have a lot of paradigms that can be used. And again, there, AI has been used, for example, in the Emirates to calculate what is the best way to dispatch all the data for it to be super fast and to come back after treatment even faster. So you have solution. And regarding security, you have, well, the ever-known blockchain. Because I also write a lot about the philosophy of blockchain, and you have a lot of companies developing a way to pretty much stock data on blockchain and to monetize it. So we have all the solutions. They're all out there. But the next step, for me, activation of all those huge amount of data that we have is going to happen through fusion. Through fusion of all the models that we have, all the knowledge that we have, all the technology that we have for healthcare. But this requires not only very multidisciplinary teams, but also transversal people that are there to manage the team, to lead all this research with a lot of different groups together. So for me, activation of the potential that we have, we're sitting on a pile of data. Well, it's going to happen through fusion, but fusion of data, through fusion of technology, through fusion of knowledge, and through fusion of academics and people. So there is a people factor, data factor. We have a lot to do, but it's there and we can do it. So thank you very much.